Hey math enthusiast, I'm here to go over the notes for section 7.1 dealing with Pythagorean Theorem. So let's start off by just refreshing exactly what the Pythagorean Theorem is. So it only deals with right triangles, and it's described as the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Typically it's written out in the form a squared plus b squared equals c squared. And we can see a, b, and c in my triangle here to the right. Now, another way to think about it is the Pythagorean theorem is essentially saying leg squared plus leg squared equals the hypotenuse squared. Now, how do I know what side the hypotenuse is? The hypotenuse is the longest side, and to identify the longest side, it's always going to be across from the right angle. So for these first couple examples, they want me to figure out the length of the hypotenuse in the right triangle, and I want to simplify that radical. So let's check out A. So one way to get started on these problems is just to identify what piece is what. So I know that this long side is the hypotenuse, x, since it's across from the right angle. And then these other two sides, the shorter pieces, are the legs. So just to recall, our formula is a squared plus b squared equals c squared. And as I wrote it out earlier, it's essentially the leg squared plus leg squared equals hypotenuse squared. So let's go through and actually replace these. So instead of leg and leg, I'm going to fill in 9 and 12. And instead of hypotenuse, I'm going to fill in x. That's what I'm trying to solve for. So now I can go through and square these. We end up with 81. I end up with 144. And I still have x squared. So it looks like after I add these two up, I end up with 225 equals x squared. Now the thing is, I just want to know what does x equal. So in order to get rid of this exponent right here, I'm going to take the square root. So the square root of x squared is going to cancel both of those out, but I'm also going to have to take the square root on the left-hand side. And thankfully, the square root of 225 is a perfect square. So I end up with x equals 15. So now when I take a look at B, we can start off the same way. Just label your parts. X is my hypotenuse. It's across from the right angle. 15 is one of my legs, and 36 is one of my legs. So if we recall our equation, a squared plus b squared equals c squared, where a and b are my legs. So when I plug in what I have, I'm going to have leg squared, 15 squared, plus leg squared, 36 squared, equals the hypotenuse squared. So I end up with 225 plus 1,296 equals x squared. So the same setup I had for the previous one. Add these two terms up, I end up with 1,521 equals x squared. And my last step is just to get x by itself. So as I said, to get rid of that square, I'm just going to take the square root. Square root on both sides leaves me with x equals 39. So I end up with a perfect square in both cases, so I did not have to simplify the radical. Now for number 2, I'm looking for an unknown side length, or in other words, one of the legs. And once again, if it isn't a perfect square, I will have to simplify that radical. So let's take a look at A. Once again, we can start off by just labeling our parts. Since the right angle is in the lower left, I know that 50 is my hypotenuse, which makes 10 and x my two legs. So once again, if it helps, write out your equation first. I know it's going to be leg squared plus leg squared equals hypotenuse squared. So now I can start to fill in my values. As I said, it doesn't matter which leg goes where. I'll put 10 in the first spot, x in the second spot, and then my hypotenuse in this case is 50 squared. So first thing I have to do is actually square my terms according to my order of operations. And next I'm going to do is get x squared by itself. So I end up with x squared equals 2400. Now in this case, unfortunately, that is not a perfect square. So what I'm going to have to do is actually simplify this radical. So what I want to try to do is break down 2400 into any perfect squares. So one I can see right away is I notice that 100 is a factor of 2400. So 100 times 24, that would leave me with 2400. But I do know that the square root of 100 is 10. So that number is going to move outside of my square root, or outside of my radical. Now, as far as 24 goes, I can actually break that down further, because one of my factors of 24 is 4 and 6. So now I know the square root of 4 is actually going to become 2. So on the outside, I have 10 times 2, and then times this radical 6. Obviously, I'm going to multiply these together because I can combine those two, so I'm going to end up with 20 radical 6. Now, since I went through this process twice, I broke it down to 124 right here, and I broke it down again into 4 and 6 right here. What I could have done, instead of starting off with 124, I could have started off with 406. And then the square root of 400 would have led me directly to 20. Now when we take a look at B, let's start off and label my three sides. I have the right angle at the top now, which tells me that across from that is the hypotenuse. 34 is my hypotenuse. So my other two sides, 16 and x, are my legs. So once again, my equation is going to be leg squared plus leg squared equals hypotenuse squared. So let's go through square our terms. Then we'll get x squared all by itself. And lastly, take the square root on both sides to get x all by itself. Thankfully, 900 is a perfect square, so it looks like x equals 30. Now, for some reason you weren't sure whether or not 900 was a perfect square, you could go through the steps to try to simplify the radical. It looks like factors of 900 would be 100 and 9. Well, both of those are perfect squares that I should recognize, which is going to give me 10, and it's going to give me 3, and then when I multiply those two together, I'm going to get my final answer of 30. Moving on to number 3, this one is definitely pretty tricky. So what they're asking me to do is solve for that value of x, but it looks like I have two separate right triangles here. So x is the hypotenuse on this red triangle here. But the problem is, on that red triangle, I really don't have a lot of information. So I have my right angle here, I'm looking for x, and I only have this short side, this short leg that's 4. Now they also give me this other triangle. Now I'm not specifically solving for anything on this triangle, they give me 9 here and 9 here and the right angle here. So the thing is, if I'm ever going to get the value for x, I'm going to need this value here, right here. Let's call it y. Well, it looks like y is part of the red triangle and part of the blue triangle. So if I can solve for the value of y in this triangle, I'll be able to solve for the value of x in this triangle. So let's get started with the blue one then. So let's label our parts. It looks like in this case y is our hypotenuse, and 9 and 9 are both my legs. So when I go to set up my equation, once again, it doesn't matter where the legs are being plugged in. We have 9, 9 equals y squared. Looks like I'm going to end up with 81 and 81 equals y squared. And finally, it looks like I end up with 162 equals y squared. So my last step is to take the square root of this. Now, 162 is not a perfect square, and it's definitely not obvious as to what factors of 162 would be perfect squares. But if you think about what I did in the step before, to get 162, it was 81 plus 81. So now when I go to break this down, let's break it down into 81, square root of 81, times square root 2. And obviously that's going to simplify down to, because 81 is a perfect square, 9 radical 2. Okay, so now I actually have a value for y, so I can go back to this blue triangle and I can plug that in. And I can plug this in to y on the red triangle, because obviously y is going to be the same value in both of them. So now for the red triangle, we'll start off the same way. So once I identify my right angle, I'll be able to figure out where my hypotenuse is, which it looks like is x in this case. So therefore 4 and 9 radical 2 are my two legs. So now when I plug this in, it looks like my leg squared plus my other leg squared. Now I'm going to put parentheses around this whole term, equals hypotenuse squared. Okay, now 4 squared, that's easy. But when I square this portion right here, you're going to be squaring both terms. So it's going to be 9 squared, which is obviously going to give me 81. And then it's going to be radical 2 squared. So let's think about what that means. Radical 2 squared really means radical 2 times radical 2. Well, radical 2 times radical 2, we can rewrite that as radical 4, which really equals 2. So what I'm going to fill in here is 81 times 2. Then when I actually multiply that together, I'm going to end up with 162 equals x squared. So I'll add these two terms up. It looks like I end up with 178 equals x squared. Now, unfortunately, 178 is not a perfect square, and my only factors of 178 would be 1 times 178 and 2 times 89. Neither of those are perfect squares, so essentially I'm just left with square root of 178. So that's my final answer for x. So 3b is definitely a little different. So in this case, it is a right triangle, even though they don't have the angle marked, so we'll add that in there. So that means x plus 4 is my hypotenuse, x plus 2 is a leg, and x is a leg. So I don't have any of my side lengths. But that's not going to change anything because I still want to set up my equation the same way. So it's still going to be leg squared plus leg squared equals hypotenuse squared. Now, when I put my terms into this equation, I want to be careful and use parentheses. Doesn't so much matter for the first term, but for that x plus 2 and for that x plus 4. Okay, now you have to remember that when you're squaring these binomials, you can't just square the x and square the 2. Remember what this number is telling you to do. It's telling you to multiply that quantity by itself. So I'm going to write out my equation a little longer. So it's going to be x squared. And then I'm going to have x plus 2 times x plus 2. On the other side, I'm going to have x plus 4 times x plus 4. Okay, now if I want to multiply these two together, I'm going to have to FOIL. So I still have the x squared in the front. Then I'm going to end up with x squared plus 2x plus 2x plus 4. And on the other side, first terms give me x squared as well. Outside gives me 4x. Inside gives me 4x. And lastly, I get 16, which I'm just going to have to squeeze in here on the side. Okay, after that, let's try to combine any like terms I can. So we have x squared and x squared I can put together on this side. So 2x squared. I have 2x and 2x I can put together on this side. So 4x and just 4. On the right hand side, it looks like I can combine my 4x's. So I just have 1x squared. I'm going to have plus 8x, and now I have room for that 16. Okay, so where do I go from here? So we have x squared terms, I have x to the first terms, and I have these constants. So what I'm going to do is I'm actually going to move everything over to the left-hand side. So I'm going to subtract x squared, I'm going to subtract 8x, and I'm going to subtract 16. So it looks like I'm just going to be left with 1x squared minus 4x minus 12. Now the key is what's left on that right-hand side is 0. So the reason I went through all that trouble is because now I can factor this. So when I factor, I'm trying to break it down into two binomials that when I multiply together are going to give me x squared minus 4x minus 12. Well, I know both of my first terms need to be x. And then I need factors of 12, two numbers that multiply to give me negative 12, that will add to give me negative 4. Well, 6 and 2 are factors of 12, and they are 4 units apart. And it has to be a negative 4, so I'm going to go with negative 6 and positive 2. Lastly, if you want to solve this after it's factored, take each of these binomials, x plus 2, x minus 6, and set them equal to 0. So now it looks like my final answer is going to be x equals negative 2 and x equals 6. So let's keep that in mind and go all the way back up to the original problem. So I had two different scenarios. I had one where x equals 6. I had one where x equals negative 2. So let's go through and sketch out what our two triangles would look like depending on what x equals. So in this case, x is on the left-hand side. It would be 6. 6 plus 2 gives me 8. 6 plus 4 gives me 10. All right, it looks like that works out. 6, 8, and 10 do form a right triangle. Now, for -2, since this value on the left is just x, I'm claiming that this leg has a length of -2. Well, the problem is you can't have any negative lengths or any negative distance. So what that tells me that x equals -2 is not a valid solution. So in this case, there really only is one solution, and that is x equals 6. So for number 4, I'm given this word problem. I'm dealing with a 20-foot ladder. It's resting against the side of a house. Base of the ladder 4 feet away from the house. I'm trying to figure out how high above the ground does the ladder touch the house. All right, well, let's just start off with my house. Draw my ground. I'll draw my ladder. So my ladder is leaning against the house. They specifically told me it's a 20-foot ladder, so I know that this side is 20 feet. They also told me that the base of the ladder is 4 feet away from the house. So the base of the ladder at this point from the base of the house is 4 feet. So they want to figure out how high above the ground does the ladder touch the house. So this is where the ladder touches the house. Straight down is the ground. That is what I'm looking for. Now, in this case, this is a right triangle. I can label my parts in my right triangle. Obviously, the ladder is going to be the hypotenuse, and x and 4 are going to be my legs. So now I can plug them into my equation. Leg squared plus leg squared equals hypotenuse squared. So let's go through and square our terms. Looks like I'm going to end up with 16 and 400. So I end up with x squared, I subtract 16, is going to equal 384. Now I'm going to take the square root of both sides. Now I can definitely break down 384. I can clearly tell it's divisible by 4, but I'm actually going to start off with something larger than that. So I believe 384 has a factor of 64. It's actually 64 times 6. That would give me 384. So the reason I started there is I'm trying to start with a big perfect square. So I end up with 8 on the outside, radical 6. I can't do anything with the radical 6, so that is my final answer. Now in this case, they were asking for approximately. So if you wanted to, you could take out your calculator, plug in square root of 384, and state that the height of the ladder is about 19.6 feet up the house.